Assalamu alaikum. My name is Abdullah Ajmal and today I will explain inside of CPU, which includes its component and its working. So let us move towards the components that are present in the CPU chip. It includes register. Registers are the basic memory circuit that are made using flip-flops, which include specific data for our program. Then we have PC, which is program counter. It tells us on which particular line of the program the execution is being done. Then we have the instruction decoder. So basically the instruction that are given are basically in the form of a human readable form or a machine language. So basically it converts it into binary form, which is easy for the central processing unit to understand. Then we have the ALU, arithmetic logic unit. It is the basic unit that performs a function which includes simple function as well as complex functions. And so basically inside a CPU we have data buses and address buses. Address buses are the paths that tells the CPU about the particular locations where the particular parts of the input and output are connected, and the data bus is the path through which the data is communicated between those parts, and the control bus is the access path which enables particular function to be performed, which includes the read and write function. So basically in this particular scenario we are using this set of instruction which so when in the start of the program the PC counter or program counter will show us 0 because none of the line is being executed. So when the program start it states A17, so which means that whatever is stored at the address location of 17 will move and will be stored in the register A. So suppose that we have 2 here, so it will move from here and will be stored on A. So now the PC counter will be 1. Now it will move on the next part. On the next line we have B, so A is moved into B. So what will happen, the value 2 which was stored in A will now move towards B and our PC counter will show 2. So in the next line we have whatever is stored in 6 moves to A. So we have here digital data lines, and so whatever will be stored at 6. So suppose that we have 3 at 6, it will move and will now be stored at A. So in the next line we have A plus B and store the answer at A. So now what is stored in A and what is stored in B moves toward the ALU, and the PC counter shows us 4 moves towards the ALU, and here the process is being formed which is addition. So 2 plus 3 equals 5. The answer is back stored into A, and now it moves towards the fifth line and which says that whatever is present in A will now move towards the memory location 7. So according to the address bus, basically the number of counters we are using, it is based on 8-bit register. So basically the last 7th bit is empty with us. So whatever the answer was at A, now it which was 5, now it will move through the data bus and move to the 7th point and it will be stored there. So the particular example that is shared here is that on the memory location 17 we have 9, and then it is moved into A, and now the value then which was stored in A now will be moved to 9, and the calculation will be performed which will be 9 plus 5, which so we have E in hexadecimal form which will be stored at A, and then this value which was stored in the part A register will now move to 7. Now let me slideshow from current slide. So as you can see it now comes from so now E will move to the point 7, and our bus, and now we have 7 stored here through the write control bus. So first we were reading and then performing our all of the our processes in LU, and the final instruction was to write. So our bus has changed to a write bus and our values are stored. So that's all from my side. Thank you.